here at the first section in chapter 6. We're going to look at the inverse functions for sine, cosine, tangent. You can read down through here on your own leisure here the definitions of range, domain, definition of function, a vertical line test, a horizontal line test, a one-to-one function, and so forth. I'm going to scroll down and jump right into here where we have our definition of an inverse. Inverses are found by changing place with the x and y values. So if you recall from algebra 2 or algebra 1 even, something like this, equation of a line y equals 3x minus 2, the inverse was x equals 3y minus 2. We probably went ahead and solved it for y so we could graph that again in slope-intercept form. Okay, the same thing's going to apply basically to a trig function. Several times through the term this year, I've written this statement up on the board or on the screen. The sine of an angle equals a ratio, or the inverse sine of a ratio equals an angle. So notice the same basically effect here that we had up with a y and x. When I change places with the angle and the ratio, or the x and the y, we insert that inverse notation so we have an inverse. So our inverses are found. Our inverses here, our sine, cosine, tangent inverse functions, are used to convert ratios to angles, and our what I call original functions, sine, cosine, tangent, are used to convert angles over to ratios. So that's the first thing we have to be able to look at is an equation or a statement and know whether we're converting an angle to a ratio or a ratio to an angle. That's complicated by the fact that now our angles can be written two ways. We can write it as 80 degrees, but we can also write that as a radian of, say, 1.234. Okay, that's a radian measure, even though it looks like a ratio. If it's written as a sine of 1.234, we're trying to convert a ratio, or so take that back. We're trying to convert an angle to a ratio, so we use our original functions. One other item or important item here, the textbooks that we're working in says that when we write a function as an inverse, as we can see with these 6 right here, our 6 trig functions, if they're written in inverse notation, that designates a specific range where we look for the angle. So you can read through here, sine is from negative pi over 2 to pi over 2. Quick little sketch here with our coordinate plane. That means I'm looking for the angle from 0 to 90, or 0 to pi over 2, and 0 to negative 90, or 0 to negative pi over 2. Okay, that's our range of values for sine. That would apply to sine, to tangent, to cosecant, and then our other 3, cosine, would go from 0 to pi, so we're looking between 0 and 180. For those, that would apply to cosine, cotangent, and also to secant. Bottom line, I guess, is this. So we have to recognize, first of all, the inverse notation, the fact that we're converting a ratio to an angle. So it's written in this form. Then, one of two things has to happen. Either we memorize or know these criteria right here that we just illustrated, or the calculator gives us a shortcut version because the calculator has these ranges pre-programmed in. You know, previously worked with the law of sines in the ambiguous case. When we type the inverse sine of, say, 1/2, we got 30 degrees. Okay, that range was programmed in from 0 to 90. If when we had the ambiguous case, we also had to check and see whether its supplement or 150 would work. But because we're written in inverse form, we're just looking for this angle, so our calculator will have that pre-programmed in. It has each of these ranges set up for us to go ahead and follow. But we will have to recognize as we go back through here whether we're looking for a ratio and angle, number one, but whether or not we're looking for an angle in radian mode or degree mode, or whether we're given an angle in radian mode or degree mode. That affects what we put our calculator in. Let's move forward here and see what we've got as far as working with our reciprocals. Here, we've also had these reciprocals before. To convert our, I'm going to mark right up above here, these convert ratios to angles. So we want to convert a ratio into an angle with our inverse function, the inverse cosecant. We don't have a cosecant function on our calculator, so we use inverse sine of 1 divided by that value. Inverse secant, inverse cosine of 1 divided by x, and so forth. Cotangent or inverse cotangent equals inverse tangent of 1 divided by x. For our reciprocal functions, over here, we're converting angles to ratios. And we've had these basic ones. We want to find the cosecant of 80, it's 1 divided by the sine of 80. Secant of 50 is 1 divided by the cosine of 50, and so on. Okay, so we have to remember those conversions as well as moving our calculator between degree and radian mode. We have several examples here to get us started. Find the inverses from the unit circle. So from our unit circle, we can pull these off, or we can even use our calculator. Another side note here is arc sine is the same thing as saying inverse sine. So another way of writing that, arc sine or inverse sine are two equivalent statements. So if we go to our unit circle, arc sine is going to tell us to look between negative pi over 2 and pi over 2, or in the first and fourth quadrants. In this case, sine is going to be negative in the fourth quadrant. Going down, we would go down to a negative 30 degrees. And we'll go ahead and put these in degrees for right now, just to make life simple. Arc cosine of 1, if we go to arc cosine is where x equals 1, x equals 1 right there at the beginning, or at 0 degrees or 0 radians. Letter C, y equals the inverse sine of negative 2. If we call our definitions of our sine function, it goes up to 1 and down to negative 1. So here that does not fall between there, so this is not defined or undefined. Inverse cosine of negative square root of 2 over 2. With cosine, we're looking at quadrants 1 and 2. So we go to quadrant 2, we find that at 135 degrees. Tangent, arc tangent is the same as inverse tangent, looking between negative pi over 2 and pi over 2. That would happen at negative 45 degrees, or in the fourth quadrant. Arc tangent of negative 1, oops, I jumped the gun here, I got ahead of myself. I was looking down at the previous problem, so let's get rid of that negative 45. Arc tangent of 0, not 1, 0 occurs at 0 degrees. Now, arc tangent of negative 1 occurs at negative 45 degrees. Inverse sine of negative square root of 3 over 2 going down to quadrant 4, that's going to put us at negative 60 degrees. Cosine of 1/2 is going to put us in the first quadrant at a positive 60 degrees. Oh, a few more here. We have some tangents. Inverse tangent of negative square root of 3 over 3. That's going to occur in the fourth quadrant at negative 30 degrees. Inverse cotangent of square root of 3 is going to occur in the first quadrant at 30 degrees. Inverse cosecant of 2 square root of 3 over 3 equals 60 degrees, and the inverse secant of negative 2 is 120 degrees. Now, just to give you a quick illustration here, let's take a look at calculator usage for letter I. I'm going to pull up the calculator here, and I'm going to make sure, first of all, I'm in degree mode since that's what I have my answers in, which I am. So I'm going to type in the inverse tangent of, I have negative, oops, not 3, how about negative square root of 3. I need to arrow in my radical, and I'm going to divide that by 3. And that's going to give me my pre-programmed negative 30 degrees. Okay, it doesn't give me 330 degrees, it gives me negative 30. Okay, so as I mentioned, all of these values are programmed into the calculator. Another side note here, let's look at letter K. Inverse cosecant, I have to use the inverse sine. Now I'm going to shortcut this one just a little bit. I put 1 over this to type it in, but because 1 divided by a fraction, I'm just going to flip that fraction over, and I have 3 divided by 2 times the square root of 3. And that will give me my positive 60 degrees. So again, calculator version also helps or works with this. The directions on some of these are going to say don't use the calculator, but honestly, it's not going to make a hill of beans difference. So it might be something that you use. Or another thing, if these were supposed to be in radian mode, I would leave it in degree mode, and then once you had 60 degrees, we all should know that's pi over 3. And we can convert those all over pretty easy. 30 degrees is pi over 6, and so on. So we can convert those just by leaving them in degree mode and flipping them back and forth, converting them back and forth. So let's move on here with some more calculator versions. I'll go ahead and pull our calculator back. It says use our calculator to evaluate, and we'll go ahead and put those in degrees where necessary. So the inverse sine or second sine of 0.9205 gives us about 67 degrees. We'll just make life simple for all these. Inverse sine, go to the nearest degree of 67 degrees. I'll type at least one more in here. So second cosine of 0.1998, and that gets us about 78 degrees. 78.5 degrees, 78.47 is what 78 degrees, just to make life simple. Our cosecant of 80, so notice this is an angle right here, so we type that in as the 1 divided by the sine of 80. And that gets us a decimal 1.10015423. Inverse or cotangent, I'm jumping the gun here, cotangent of x equals 1.732. So right now, x is our angle, which means 1.74 or 732 is our ratio, which means this is the same thing as the inverse tangent of 1.732 equals x. Now we use our inverses. So we do second tangent, I'll write this out, inverse tangent of 1 divided by 1.732, and 1 divided by 1.732 gives us about 30 degrees. Notice how D and E are written differently, but they're saying the same thing, because here we went to this statement, which now kind of matches up with this. So the inverse cosecant is the inverse sine of 1 divided by that number, or 1 divided by 2. And in this case, we also get 30 degrees. Now, as we scroll down here, we've got more problems to do, so I'm going to pull my calculator back up here, try and get it out of the way. Okay, so the inverse cotangent of -5. We use our inverse tangent of 1 divided by 5, and that gives us our angle of about 11 degrees. The secant of x, notice that x is our angle, so 5.43299 is our ratio, or in other words, we have the inverse secant of 5.4329999 here, and we type that in as the inverse cosine of 1 divided by 5.43299, and that gives us an angle of about 79 degrees. Okay, so notice two different statements solve the same way by recognizing whether or not we have a ratio or an angle. Letter H, we also have x here. Cosecant of x is our angle, so the inverse cosecant of 3.4448964 is our ratio. We want to convert that over by using inverse sine of 1 divided by 3.4448964, and that gets us an angle of about 17 degrees. Moving on to letter I, arc cosine. Remember, arc cosine is the same thing as inverse cosine. So inverse cosine of -0.3333 was written with an inverse. This is our ratio, so I just type that in straight as I have it written. -0.33341125, and that gets me about 109 degrees. Arc sine, again, same thing as inverse sine. Inverse sine, this is a ratio, so inverse sine, second sine of 0.87965778. and that gets us about 62 degrees, 61.6 degrees. A couple of complex ones down here, what I'll call compound, because we have two functions here. I'm going to go one step at a time. So I'm going to start inside the parentheses, the inverse cosecant here, inverse 3.78. That tells me 3.78 is a ratio. So second sine of 1 divided by 3.78 gives me an angle of about 15.34 degrees. So now we're finding the cotangent of 15.34 degrees. That is an angle measure. So angle measures we type in as 1 divided by the tangent of that value. And that gets us a decimal of 3.6453257774. So there is our value for that first compound function. Let's scroll down to make sure we have everything on here that we're going to finish on this page. Keeping the calculator up here. Cosecant of 38. Now notice 38 is an angle measure. So we type that in as 1 divided by the sine of 38. And that gets me a decimal value of 1.624. 269245. Now I have the inverse secant of that, so that's a ratio. So inverse cosine of 1 divided by that value, and that will convert it back to an angle of 52 degrees. There's what we're looking for, 52 degrees. And one more time, inverse tangent of 2.56. 2.56 is a ratio. Tangent's already on here, so 2.56 is an inverse tangent, converts us to an angle, gives us the cosecant of 68.66 degrees. That's a degree measure, so we convert degrees over by doing 1 divided by the sine of that angle, and that gets me about 1.07359. Converting it back to a ratio. Okay, so we're converting back and forth between ratios and angles here by using our calculator and the trig functions, along with our reciprocal functions. So make sure we understand the difference between these two types of scenarios right here as we move forward. A few more to get through here. These can actually be solved fairly simply without using the calculator. Sine of the inverse tangent of 3/2, so kind of a longer explanation. If we work step by step, if we did the inverse tangent of 3/2, that would convert us to an angle. Okay, that would give us sine of, say, 45 degrees, just making up a number. Then, when we take the sine of 45 degrees, we convert it back to a ratio. So we're skipping that intermediary step, we're just going to simply identify x, y, and r from our inverse function here. This tangent is y over x. So I have a 2 and 3. 2 squared plus 3 squared is 4 plus 9, or the square root of 13. And now sine of that angle is going to be y over r. So it's 3 over the square root of 13, or that simplifies to be 3 times the square root of 13 over 13. So all we did was find x, y, and r based on the fact we're converting this. Let me get rid of these circles here. We're converting that part in parentheses, our compound function. We're converting the tangent over to an angle. Then we're converting that angle back to the ratio. Well, the ratio is going to come from the x, y, and r, so we might as well go straight to there and avoid the angle part of that. On top of that, that gives us an exact value as opposed to our calculator giving us an estimated value. So let's go on here. Tangent of the inverse cosine. So notice that we're converting our ratio to an angle here, then our angle back to a ratio with a tangent. So we'll go with x being -5, y and r being 13, which means we know our triangles. Y is 12. Tangent is y over x, so it's 12 over -5 or -12 fifths. Okay, so again, a fairly simple problem if we recognize that we're working around those inverse and regular functions. Our third one here is a little bit more complicated because we have a double angle because of this 2. So I'm going to rewrite this as the cosine of 2a. I'm going to use one of my two versions there, cosine squared a minus sine squared a, for my double angle. We remember those from our work in chapter 5. Going back here, We want to identify x, y, and r because arc tangent, same thing as the inverse. Oh, we have a 4 and a 3. That does give us a 3, 4, 5 triangle this time. And now we can find our double angle by using these values. Cosine is 3/5, so 3/5 squared. Sine is 4/5 squared. So that gives me 9/25 minus 16/25, or negative 7/25 as my value for this overall compound function. Okay, so a couple more along those lines here that are kind of trickier using our angle identities. Notice I have a sum here, so I have the cosine of A plus B, which is the cosine of A times the cosine of B, plus, oops, not plus, how about a minus, sine A sine B. Notice we have two angles here. We have one for the arc tangent, one for the arc sine. Arc again means inverse. So for my tangent, or for my angle A, which is the tangent, x, y, and r, square root of 3 over 1. 1 squared plus 3 is 4. Square root of 4 is 2. And then for angle B, I'm using the 1/3. So x, y, and r. Y is 1, r is 3, which means I have the square root of 8 here, or 2 square root of 2. And now I substitute in what we know. Cosine of angle A is 1/2. Cosine of angle B is 1/3. Oops, try that again. I would put sine of B, not cosine of B. Cosine of B is 2 square root of 2 over 3, minus the sine of A, which is the square root of 3 over 2, and the sine of angle B, which is 1/3. Oh, here I have 2 square root of 2 over 6, minus the square root of 3 over 6, or 2 square root of 2 minus the square root of 3 all over 6. Okay, so a little bit more in-depth version there of our compound function using some of our identities back from chapter 5. One more time here, let's do tangent. Notice the 2 here. So I have the tangent of 2a. I'm just going to replace the arc sine with an a. I'm going to expand that out. That is 2 times the tangent of a over 1 minus tangent squared a. Come back over here and identify x, y, and r. We just have the one angle this time, the a. So sine is y over r, so I have 2/5. If I do x squared plus 2 squared equals 5 squared, I'm going to have the square root of 21 for my x value. So let's make our substitutions over here. 2 times 2 over the square root of 21 over 1 minus 2 over the square root of 21 squared. So this gives me 4 over the square root of 21 and 1 minus 4/21. I'm going to slide down here to finish. So I'm going to rewrite my numerator in simplified form. So I change 4 square root of 21, or 4 over square root of 21 to 4 square root of 21 over 21. And then 1 minus 4 over 21, I'll write it out in 2 steps. 1 is 21 over 21 minus 4 over 21. Gets me 4 square root of 21 over 21 over 17/21. I'm dividing fractions, so 4 square root of 21 over 21 times 21 over 17. The 21s cancel, and we have 4 square root of 21 over 17. Okay, so we have some work to do there with simplifying those expressions, but that is a quick look at the first section in chapter 6.